Non-metallic 3.0 Pancake boxes rated at 3.5 cubic inches are available. These boxes are typically manufactured using polycarbonate or acrylonitrile butadiene styrene, also known as ABS plastic. Whether or not these boxes are permitted depends on the specific regulations in your jurisdiction. Certain jurisdictions have particular stipulations concerning the volume rating of Pancake boxes, which are based on the number of devices they accommodate. For example, the 2020 National Electrical Code, NEC Section 314.28, A4 mandates that a Pancake box possess a minimum volume rating of 5 cubic inches when housing up to 4 devices. Furthermore, it must have a volume rating of 7 cubic inches if it is housing 5 or more devices. It is generally not recommended to use boxes that do not meet the appropriate size requirements. There are several potential issues with using undersized boxes. Firstly, devices can overheat as a result of insufficient space for heat to dissipate. Secondly, properly installing devices can become difficult. Thirdly, the likelihood of electrical shorts and fires increases. It is recommended to use Pancake boxes that adhere to the volume rating requirements of the jurisdiction where the electrical work is being done. If using undersized boxes is permitted, it is important to follow some guidelines. Firstly, exercise caution when installing devices, ensuring that they are properly secured and have sufficient space for heat dissipation. Secondly, carefully follow the manufacturer's instructions for the specific box that is being used. Thirdly, regularly inspect the box to ensure that there are no signs of overheating or damage. The National Electrical Code, NEC, provides detailed guidelines on box fill calculations to ensure safe and compliant electrical installations. The NEC specifies the maximum number of conductors, devices, and fittings allowed in an electrical box based on its volume. These requirements are crucial for preventing overheating and ensuring the safe operation of electrical systems. To determine the correct box size, you need to calculate the total volume required for all conductors, devices, and fittings that will be housed in the box. Firstly, count the number of conductors in the box. Each conductor has a volume allowance based on its size as specified in NEC Table 314.16. Secondly, account for conductor equivalents. For example, each equipment grounding conductor counts as one conductor based on the largest equipment grounding conductor entering the box. Thirdly, consider device fill. Each device, such as a switch or receptacle, counts as 2 conductors based on the largest conductor connected to the device. Fourthly, add any additional volume allowances for fittings such as cable clamps or support fittings. Once you have calculated the total volume required, compare it to the marked volume of the electrical box. The box must have a volume equal to or greater than the calculated volume. Using a box that is too small can lead to overcrowding, which can cause conductors to overheat and potentially lead to a fire. If the calculated volume exceeds the box's capacity, you must use a larger box. It is essential to follow these box fill calculations to ensure the safety and compliance of your electrical installations. Always refer to the latest edition of the NEC for the most up-to-date requirements and guidelines. Remember that local codes and regulations may vary, so it is important to check with your local authority having jurisdiction to ensure compliance with all applicable rules. The NEC provides specific tables for calculating box fill based on conductor size and the type of fittings and devices used. These tables provide the minimum volume required for each conductor, device, or fitting. To use these tables effectively, you need to accurately identify the size of the conductors and the type of devices being used. For example, a typical 14 American wire gauge (AUG) conductor requires a certain volume allowance, while a 12 AWG conductor requires a larger allowance. Similarly, different types of devices, such as switches, receptacles, and wire connectors, have different volume requirements. In addition to conductors and devices, you also need to account for any fittings used in the box, such as cable clamps, support fittings, and grounding connectors. These fittings take up space inside the box and must be included in a box fill calculation. It is important to note that the NEC specifies different box fill requirements for different types of boxes, such as metal boxes, non-metallic boxes, and extension rings. Each type of box has its own volume limitations and requirements, so it is essential to use the correct table for the specific type of box being used. Once you have determined the volume required for all conductors, devices, and fittings, you can compare it to the marked volume of the electrical box. The box must have a volume equal to or greater than the calculated volume. If the calculated volume exceeds the box's capacity, you must use a larger box. Overfilling an electrical box can lead to overheating and potentially cause a fire. By following the NEC guidelines for box fill calculations, you can ensure the safety and compliance of your electrical installations. Always refer to the latest edition of the NEC and consult with a qualified electrician if you have any questions or concerns. The NEC also addresses the proper installation of electrical boxes, including requirements for securing and supporting the boxes. Electrical boxes must be securely mounted to a structural member of the building, such as a stud or joist, to prevent them from moving or falling. The NEC specifies different methods for securing boxes depending on the type of box and the type of wall or ceiling construction. For example, boxes installed in drywall walls may require the use of special mounting brackets or support straps to ensure they are securely fastened. In addition to securing the boxes, the NEC also requires that they be properly supported to prevent them from sagging or pulling away from the wall or ceiling. This is particularly important for boxes that are mounted horizontally or that support heavy devices, such as ceiling fans. The NEC specifies different methods for supporting boxes, including the use of support wires, metal straps, and adjustable brackets. It is important to follow these requirements to ensure that the boxes are properly supported and that the electrical connections remain secure. The NEC also addresses the use of box extensions and plaster rings to increase the volume of electrical boxes. Box extensions and plaster rings can be used to provide additional space for conductors, devices, or fittings without having to replace the entire box. However, the NEC specifies certain limitations on the use of box extensions and plaster rings. For example, the extension or ring must be securely attached to the box and must not reduce the mechanical strength or fire resistance of the box. It is important to follow these limitations to ensure that the box remains safe and compliant. Always refer to the latest edition of the NEC for the most up-to-date requirements and guidelines on the installation of electrical boxes. Consult with a qualified electrician if you have any questions or concerns about proper installation methods. In addition to box fill calculations and installation requirements, the NEC also addresses the proper grounding of electrical boxes. Grounding is a critical safety measure that helps to protect against electrical shock and fire hazards. The NEC requires that all metal electrical boxes be grounded to provide a low impedance path for fault current to flow back to the source. This helps to trip the circuit breaker or fuse in the event of a ground fault, preventing a dangerous buildup of voltage on a metal box. The NEC specifies different methods for grounding metal boxes, including the use of grounding screws, grounding clips, and grounding conductors. The grounding conductor must be properly sized and connected to the box and to the building's grounding system. It is important to ensure that the grounding connection is secure and that the grounding conductor is protected from damage. The NEC also addresses the grounding of non-metallic electrical boxes. Non-metallic boxes do not require grounding because they are made of insulating materials that do not conduct electricity. However, the NEC requires that any metal devices or fittings installed in a non-metallic box be grounded to provide a path for fault current. This can be accomplished by connecting the metal device or fitting to the building's grounding system using a grounding conductor. It is important to follow the NEC requirements for grounding electrical boxes to ensure the safety and compliance of your electrical installations. Always refer to the latest edition of the NEC and consult with a qualified electrician if you have any questions or concerns about grounding methods. Using the correct tools is vital for safe and efficient electrical work. Firstly, always use insulated tools to protect yourself from electrical shock. Secondly, have a variety of screwdrivers, including flathead and Phillips head, in different sizes. Thirdly, use wire strippers to remove insulation from wires without damaging the conductors. Fourthly, employ pliers for gripping, bending, and cutting wires. Fifthly, a voltage tester or multimeter is essential for checking for live circuits and verifying voltage levels. Sixthly, use a conduit bender for bending electrical conduit. Seventhly, fish tape is helpful for pulling wires through conduit. Eighthly, a circuit finder can help identify circuits quickly. Ninthly, a level ensures boxes and fixtures are installed straight. Tenthly, a measuring tape is needed for accurate measurements. Always follow safety precautions when working with electrical tools and equipment. Before starting any electrical work, turn off the power to the circuit at the breaker box. Use a voltage tester to confirm that the power is off before touching any wires or components. Wear safety glasses to protect your eyes from debris. Use insulated gloves to protect your hands from electrical shock. Keep your work area clean and organized to prevent accidents. Never work on electrical systems when you are tired or distracted. If you are not comfortable performing electrical work, hire a qualified electrician. Always follow the manufacturer's instructions for all electrical tools and equipment. Inspect your tools regularly for damage and replace them if necessary. Proper planning and preparation are essential for any electrical project. Firstly, determine the scope of the project and gather all necessary materials and tools. Secondly, review the electrical code requirements for the specific type of work you are performing. Thirdly, create a detailed wiring diagram to plan the layout of the electrical system. Fourthly, obtain any necessary permits or inspections from your local authority having jurisdiction. Fifthly, turn off the power to the circuit at the breaker box before starting any work. Sixthly, use a voltage tester to confirm that the power is off before touching any wires or components. Seventhly, wear appropriate safety gear, including safety glasses and insulated gloves. Eighthly, keep your work area clean and organized to prevent accidents. Ninthly, follow all safety precautions and best practices for electrical work. Tenthly, test the completed electrical system to ensure that it is working properly and safely. By following these steps, you can ensure that your electrical project is completed safely and successfully. Remember, electrical work can be dangerous if not performed properly, so it is important to take your time and follow all safety precautions. If you are not comfortable performing electrical work, hire a qualified electrician.